In this video, we're going to go over section 6.2, a review from a chapter 6 section. So on question number 9 is asking you to find the critical value T sub C at a confidence level of 0.99 and with a sample of 10. So when you're working with T value, in this case you're looking for T of 0.99, we need to also find the degrees of freedom. So the degrees of freedom is found by subtracting 1 from the sample mean. So in this case, this is going to be T of 0.99, comma, 10 minus 1. So you're looking for the T value, the confidence of 0.99, degrees of freedom of 9. So this will be a different table from the other ones that we were using. So the t-score table is also called the t-distribution. So you're going to find on the left-hand side degrees of freedom. You go down to 9, and then over you're going to look for the confidence. In this case is 0.99. So 9 over to the one that is 0.99, and will be the last one, the last column here. So that is 3.250. So that is the value for your t-score. So I'm going to make a little chart in here to show you where it came from. So the degrees of freedom here, we found 0.90, we found number 9 because it is n minus 1. There are 9, the sample size minus 1, and then look over for the confidence level of 0.99, and that was 3.250. So that is going to be the T value, and that is the letter C. So again, I like to color it to emphasize that that's the final answer. So the next question is giving you, is asking you to find the t-score, critical value, and the confidence is 0.95, sample size of 16. So you're looking for the T of 0.95, degrees of freedom 16 minus 1. So we're looking for the T value 0.95 and 15. So in the T table, the degrees of freedom are going to be 15. And then you're going to find the confidence of 0.95 in the table. So you're going to look at 15 and 0.95 across. So 15 and 0.95 is the one in the middle. So it's 2.131. That will be the value for T, 2.131, and that is answer D. Okay, so that is a simple process to find your T value or T critical value. So the next question is asking for the margin of error. So in this section, the margin of error is using the sample standard deviation because the population standard deviation is unknown. So again, you'll refer to the formula sheet, and in the formula sheet, when the population standard deviation is unknown, you're going to use, instead of the z is going to be the T value multiplied by the sample standard deviation divided by the square root of the sample size. So the formula is E equals, that's the letter for the margin of error, and it's found by multiplying the T, in this case the T of 0.90, degrees of freedom 16 minus 1, so degrees of freedom will be 15, and once you find that value, we'll multiply it by the sample standard deviation, that in this case is 2.4, and the square root of the sample size, that is 16. So the T value of 0.90, we're going to go to the T distribution, and we're looking at 15, and the margin of error, the confidence is 0.90. So 15 and 0.90, that is 1.753. 1.753. So 1.753 will be multiplied by the sample standard deviation divided by the square root of 16. So we tend to round that. If you look at the answers, everything is rounded to 2 decimal places. So we're rounded to 2 decimal places. So 1.753 multiplied by, open parentheses, 2.4 divided by second square root of 16, and press enter, and I'm getting 1.05. So that is your margin of error, and that matches response B. Remember that the final answers, or the answers, are on the last page of the handout for the review. So we make sure we make it orange before we move on. So the next question, number 12, it says find the value of E, the margin of error, for the confidence of 0.90. N is 10, the sample size, and the sample standard deviation is 3.2. So margin of error, again, it refers to E. So we have to find the T value at the 0.90. Degrees of freedom 10 minus 1, so that will be a 9. We multiply that by the sample size and divide it by the square root of 10. So we're going to go to the table to find the T of 0.90 and 9. So 9 across and 0.90 is the second number, 1.83. When you go across, 1.833. So 1.833 multiply by the sample standard deviation divided by the square root of the sample size. So clear. And 1.833 multiplied by 3.2 divided by second square root of 10, and press enter. I'm getting 1.85 followed by 4, so 1.85, and that is answer B. So answer B is the correct answer for this exercise. So 1.85. The next question looks like an essay, so long. So we'll read it, but it's a short answer. You just have to determine whether you can use the normal distribution, the t-distribution, or if you cannot use any one of them. So we'll read it carefully. In a random sample of 28 families, so the sample is 28. In that sample, they found that the average weekly food expense, so what that means is that the average sample mean is $95.60 with a standard deviation. So that refers to the sample standard deviation of $22.50. Determine whether a normal distribution, t-distribution, should be used, or whether neither or neither of these can be used to construct a confidence interval. And it says it is normally shaped, so it has a normal distribution shaped. So even though the sample is less than 30, it says that it has a normal distribution shaped, since it's giving you the sample standard deviation. So notice that it doesn't say sample standard deviation, but it's implied by the fact that it says they took a random sample of 28 families and they found that the average was this and the standard deviation of that. So since that information is based on the sample of 28 families, it is implied that is the sample standard deviation. So when you don't have the population standard deviation, you have to use a t-distribution. So it is because it is normally distributed. The main thing is you have a sample standard deviation, you don't have a population standard deviation, even though the sample size was small because it was not 30 or more. So that's how you answer that one. So we'll go to the next page. And we just have 3 questions left. So we keep it similar to the other one. We have to decide whether it's a normal, t, or none of them. So a random sample of 60 college students. So they took a sample of 60 college students. So n equals, 40 college students. And that sample has a mean of $3,120 over the summer months. So that's the mean earnings of $3,120 over the summer month. Assume the population standard deviation. So it tells you in here the population standard deviation over the summer month for college students. So the population standard deviation is given as $677, and the distribution of earnings over the summer months for college students is normally distributed. So since the population standard deviation is given, this tells you that you are able to use the normal distribution, which is the z-score. So you can use the normal distribution. So this one is C. You can use a normal distribution on question 14. I'm sorry, it's not letter C. If you look in here, it's letter A. Normal distribution is A. I don't know what I was looking at. Okay, so the next question, number 15. A random sample of 15 statistics textbooks has a mean price. Okay, so they took a sample of 15. Note that is less than 30. And they say, well, the sample mean for the book prices is $105. And the standard deviation, the sample standard deviation is $30.25. Determine whether it's a normal T distribution or neither one of those two. Assume the distribution of statistics textbooks is not, it says that is not normally distributed, and the sample size is not at least 30. So this one is, it cannot use normal or T distribution. So that's why this is the one that is C. So neither the T distribution or normal distribution. So that's why the answer is the letter C. Again, the sample is less than 30, and it says not normally distributed. Not normally distributed. So the last question for section 6.2, they're asking us to construct a 95% confidence interval for the population mean. Assume the population has a normal distribution. So the confidence is 95%. That is equal to 0.95. So I know that I'm going to, I'm in section 6.2. So I'll keep reading, but this will mean that I need to find the t-value. So confidence interval for the population mean. Assume the population has a normal distribution. A sample is 20, so n equals 20. That makes the degrees of freedom are the sample size minus 1. So this is 20 minus 1 is 19. So basically this information is provided to you so that you can find the t of 95 with degrees of freedom of 19. So if you look at the table, at the t table, you're going to look at 19 and 0.95. So the t distribution table, 19 and 0.95. So 19 and 0.95, that will be the one in the middle, 2.093. So your t value, 2.093. Ooh, that's the tape. Okay, 2.0, let me use a pen here, 2.093. So that's my t value that I will be using, t equals 2.093. So in order to find the confidence interval, if you recall from the previous section, we are looking to find this x bar minus the margin of error, and that will be an estimate of that the population mean is found within those two values with a 95% confidence the more you repeat the experiment. So the sample mean, it says the 20 students, the mean annual earning is $3,000, so the x bar is $3,120, and with a standard deviation for that population, for that sample size, I apologize, is 677. So we're going to have to find the margin of error. We have the sample mean, so I can go ahead and kind of like set it up, and then all I have to do is insert the margin of error E. But all this information was given to us so that we can find the margin of error. Again, that formula will be provided to you. So that is found by the t multiplied by the sample standard deviation divided by the square root of the sample size. So here the E is provided by, having technical difficulties with the paper, so the E, the T is 2.093. I'm trying to squeeze it here at the bottom. 2.093 multiplied by the sample of $677 divided by the square root of 20. So we'll enter that in the calculator. Let me remove the paper so that you can see it fully. I'm using my notepad. So there we go. So it's at the bottom here. So to find the E, I will enter in my calculator 2.093 multiplied by, first we need to turn on the calculator. That usually helps. So 2.093 multiplied by 677 divided by second, square root of 20, close, equals, so we're getting $316.84. $316.84. If we look at the answers, none of them have decimal points, so I'm going to go ahead and round this to a whole number of 317. So I'm subtracting 317 from the left side and adding 317 on the right side. So you subtract 317 from 3,120 minus 317. So the left side is going to be 2,803. And the other side, it will be 3,120 plus 317. And that is 3,437. So the money symbol, because we're working with money. And again, we like to express that in parentheses. So enclosed in parentheses, that will be the interval notation. So this is the same as answer C. So this number 16 is letter C. So I hope this helped you. This was helpful in helping you understand sections 6.2. Thank you for your attention. Goodbye.